Continuing on, we're going to start to learn about logarithms. And the whole premise with logarithms is that they are the reverse. It's actually the inverse operation of exponents. So if you recall back when we did inverses, and we did problems like y equals 2 to the x, we talked about what it meant to be a one-to-one function. And the quick answer to this one is yes, 2 to the x is a one-to-one function because it passes the horizontal line test. You might, we talked about it a long time ago as to that being the case. So what on earth does that mean? Is that means that an inverse exists. And I might be getting a little bit ahead of myself, because you might be sitting there and saying, how did you even come up with this? Now remember that when we did 2 to the 0 power, we got 1, so that's this ordered pair. And then 2 to the first power, well, something to the first power is itself. That's why we have the ordered pair 1, 2. Maybe I'll jump over to this one, that 2 to the third power. That means 2 times 2 times 2, which is 8. So we have the ordered pair 3, 8. 3, 8. And then also negative exponents turn them into fractions. Now, if we go back to our inverse, what we hopefully learned way back then is that we switch x and y. The inverse, we switch our x and y coordinates. So, well, you can't really see all of the points there, but if we had 0, 1 was an ordered pair, then 1, 0 will be an ordered pair. And 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. I just talked about 3, 8 is going to become 8, 3. So I can plot some of these ordered pairs. 1, 2, 3, 4, up 2. And then 5, 6, 7, 8, up 3. But then also, don't forget about these fraction ones with the negative exponent. So if we switch x and y, it's going to become 1/2 negative 1. And then 1/4 was negative 2, and then 1/8 becomes negative 3. And so there's two things that I want you to keep in mind with this. One of them is with the exponential function, let me switch colors, we did not cross the x-axis. So if we're switching x and y, then on this part, I'll just write it right here, we do not cross the y-axis. So it's very important when you do that. And then you may remember this one, so let me highlight it, that when we do the graph of the function and its inverse, it's a reflection symmetry over that line y equals x. That's why y equals x is on there. And I hope you remember, but if you don't, mention it. I'll even do this in yellow. Is that the distance away from that is the same on the other side. You can't even see that yellow. I'll pick another light color, I guess. That the distance away from that diagonal is the same distance on the other side. So this one's one diagonal away. It's got to be one diagonal on the other side. All right, that's enough of that. And so what we actually do is we come up with a new function for the log. We call it log. Now, before I do that, let's mention that f of x is equal to 2 to the x power. Now, remember, f of x is the same thing as y equals. And I hope you remember, I'm going to write it out, that when we do the inverse, we switch x and y. And so what we're looking at is x equals 2 to the y power. And then from there, what we did is we solved for y. Well, the issue that we have is we don't have a function until we create a new one. And that is created like this. So we call it log. It's just an operation. Log is short for logarithm. And we write it out. You've probably even noticed on your calculators there's a log button. That's what it does. It's the inverse of exponential. Now, I had a teacher that taught me this a long time ago, and so I'm going to show it to you real quick. She wrote it out as log base b of x is equal to y. Let me write that out because that's how we pronounce it. Log base b of x. Because if you go back to this exponential, we also called this the base. So notice that those bases are the same. So what my teacher did a long time ago is she called it like a boot method. She drew, I would debate whether or not it really even looks like a boot, but that's what she did. And she said, well, b to the y power is equal to x. I don't even know if you see the boot with shoelaces on there. But it stuck with me, so I figured I could talk about it the same way with you. So here's our reality on how to do this problem. Is I hope you would look at this and say, okay, yeah, I know that b, let's make up a number instead of b. Let's use base 2, because we just did that. That 2 to the third power is equal to 8. We've been talking about that. So what that means is if I write it in log form, log base 2, remember that's what we call this base, of 8 must be equal to 3. And the reason for that is that boot method. I'll switch colors again, is draw a boot in here, that 2 to the third power is equal to 8. So it'll be to your benefit if you can rewrite exponents into log form or vice versa. I will also point out, because there's going to be a lot that we learn, is under the math key on your calculator, and if you scroll down, it's actually faster if you hit the up arrow a couple times, and you find log base. The calculator actually does this for you. And like I said, there's going to be enough problems where me showing you how to do this is not going to change your grade that much. But I need you to understand that log base 2 of 8 is equal to 3 because 2 to the third power is equal to 8. They undo each other. So we have lots of problems where we do this, and I honestly didn't know that the very first one was going to be the problem I just talked about. And I think it's good practice if you go ahead and tell me the answer, and you also tell me the exponential form that it's because 2 to the third power is equal to 8. That's where I wrote BC for because. So when you get to the homework, if you just want to tell me the answer, that's fine. You know, if I'm looking at this, I know right away that that answer is 2. Why is it 2? Well, 4 squared equals 16. If you want to draw a boot over and over again, then go for it. 4 to the second power is equal to 16. I'm not sure how familiar you are with all of these numbers, but 5 to the fourth power is 625. Like I said, feel free to use a calculator. You know, is it true that 5 to the fourth is 625? Yes, it is. Here's another shortcut. If you don't want to hit the math key, you can actually hit alpha window, and you can see that the fifth option down is log base as well. Log base 5 of 625 equals 4. Now here's another thing, is we live in a base 10 system, so all of your calculators do this. So if you ever see a problem that just says a log of a number, it's implied to be 10. And let me show you real quick. So like your phone calculator has a log button. And just to point it out, if I hit alpha window, the fifth option, and write in base 10 of 100,000, I get the same answer. This one is 5. So again, having a calculator sometimes is just helpful in helping you understand it. But if I look at this next one, I think you are all capable of being able to figure out that this answer is -2. Why is it -2? Well, having a negative exponent will make it into a fraction, and then 6 squared gives you 36. So same idea with the next one, is that's -4. This next one, let me just give you the answer and I'll talk about why it's 1/2. Well, if you go back to your boot method, I've been using this color for boots, and you go to type in that you have 5 to the 1/2 power, just remember that when we did the 1/2 power, that's the same thing as the square root of 5. And that might be helpful on this next one, Because sometimes what I'll have students do is I'll just have them write an x over here, and I'll just say, okay, well, 3 to what power would give you 9, well, the 5th root of 9. Well, what you can think about is 9 is the same thing as 3 squared, and the 5th root would be to the 1/5 power. So coming back up here, let's go ahead and change it back to this purple, that this answer would be 2/5. And again, the calculator would tell you that answer. So even though I'm telling you, the calculator does this for you, I still want you to be somewhat familiar with it, especially when we get into problems like this. Like, you still need to understand the y-intercept is when x equals 0. Well, if I asked you to do that, then plug in 0 for x, we're looking at log base 2 of 0 plus 8 plus 9. I should probably talk about the order of operations as well. Just so you're aware, whether you call them PEMDAS or GEMDAS, I actually prefer grouping symbols instead of parentheses. So if you're familiar with PEMDAS, don't judge me. But logs, because they're the inverse of exponents, you do them at the same time as exponents. So yes, you do 0 plus 8 first, so that's just 8. So we're looking at log base 2 of 8, and then add 9 to it. But the next step is to do log base 2 of 8. And we actually did that above there. That was 3. And then once you add 9 to it, we're going to get the correct answer is 12. So option 1 on that one. So another reason why I like this is that you can think critically about this, is you can go through all the answers. Now, you're welcome to use a calculator, but just think about it for a second. If you did 3 to the 1st power, that's 3. 3 squared, that's 9. 3 cubed is 27. If you did 3 to the 4th power, is 81. Now, why am I stopping there? Well, think about it. That 40, this number, is sandwiched in between 27 and 81. So what does that mean for our answer is it's got to be squeezed between 3 and 4. Now, I'm well aware that some people, that just doesn't make sense. I hope it makes sense, obviously. It's critical thinking skills. But you are allowed to use a calculator. If you hit alpha window and grab that log base 3 of 40, the only thing is there's not much thinking going on here. That the answer has to be between 3 and 4. It's 3.4. If you wanted to, you could also evaluate log base 3 of 27. That's essentially what I did here. And then do log base 3 of 81. Again, that's essentially what I did. To see my answer needs to be between 3 and 4 because 40 is between 27 and 81. And then I already talked about this last one, about the common log. I guess I forgot that I was going to say that down here. So anyway, so you're welcome to use a calculator, but this answer is going to be 2, and just quickly think about it. Even though there's not a 10 written here, it's because 10 squared equals 100. If you want to draw on the boot and you want to put in the 10 in there, then go for it. So looking at the next one, I know it's a negative answer in order to get a fraction, and then to the 3rd power. That 10 to the negative 3rd power gives me 1 over 1,000. And then this last one, again, feel free to use a calculator, but it's 1/2. Why? 10 to the 1/2 power is the same thing as the square root of 10. And now you should be ready for your homework on 10.5.